Okay, I guess we can start our session today. Good morning, everyone. Good morning, ladies and gentlemen in our audiences. My name is Nasrin Sadeghianpour. I'm a senior AI and smart grid scientist in BluWave-ai. And it's an absolute pleasure for me to have a discussion about how smart cities are leveraging AI for clean energy with all star panelists joining me today. So before indulging to our discussion, let me give a quick introduction of our company, BluWave-ai. We are a Canadian company with focus on artificial intelligence for clean energy. We have developed a distributed computing platform that leverages the big data and high-performance computing to deliver AI-enabled software for optimum prediction and control. BluWave-ai has brought together a variety of skill sets, including distributed AI expertise, optimization and control theory experts, and energy market experts. We help various sectors like utilities, microgrid operators, and fleet operators to leverage their data into information and real-time intelligent decision-making to improve the use of renewable generation and increase EV adoption. We have deployed our software at a number of cities around the world and are active in at least 3 continents currently. We take pride in having developed and deployed the first real-time AI energy dispatch in a Canadian electrical utility with 47% wind penetration, which is one of the largest in the continent. So with that introduction, let me give a bit of a context to the issues that we are addressing today. So once humans recognize the urgency and necessity of combating climate change, we have started our migration to distributed clean energy resources and electrification of transport. But this migration has come with various challenges. First of all, our power grid started to revolutionize to accommodate this transition, which brought complexity and uncertainty to the operation of the power grid. Because from one side, we are resorting to energy resources over which we have no control, and furthermore, they are intermittent sources of energies. On the other hand, we are integrating electrification to our transport, which adds the extra demand to our load. And we need to accommodate this load in spite of such uncontrollable energy generation. So furthermore, there are lots of degrees of complexities that are introduced with these variables that mandates the data-driven algorithms. This is what we will be talking about today. Today, we generate billions of measurements from various points in our power grid and from our operations. So AI takes into account the millions of variables and data points, including weather, demand, location, our generation assets, our operations assets, etc., and has to proactively decide on optimum action to operate such complex system in real time. So in today's discussion, we are going to focus on the electrification of transport, and with our experts today, we will explore the challenges of such electrification in the real world. So I have Francis Lalonde, Vice President of Transportation in Walmart. Francis is going to give us real-world insights on how they operate an EV fleet in Walmart. And next I have Frank Muehlon, President of E-Mobility Division in ABB. Frank will take us through the complexities of charging infrastructure planning to facilitate the EV adoption. And last but definitely not least, I have Laurie Heuff, Director of Distribution Engineering and Asset Management in Hydro Ottawa. So Laurie will take us through what electrification of transport means to grid operator, now that the grid operator has to become the source of fuel for these assets. So without further ado, let me start with our first panelist, Francis. So Francis, could you please take us through we know that in Walmart, you are targeting zero emissions by 2040. That's an impressive goal. So could you tell us more about how Walmart achieves this and what is the role of your organization in this transition?
Absolutely, Nasrin, thank you for the introduction. Thank you for inviting us, and happy to be here. Exciting to be part of this awesome topic today. So again, Francis Lalonde, the VP of Transportation for Walmart Canada. I really like the topic of smart city and sustainability. It really connects well for us with the Smart Transportation Playbook, which is what we have been running for the last few years. There's a couple of pillars of the Smart Transportation Playbook, and one is that journey to sustainability. Right? So if we decompose all this, there's the big target, as you mentioned, Nasrin, to be zero emission by 2040. Then you break this out in Canada, in transportation, we committed to be alternately powered by 2028. So very aggressive commitment. We're very proud of that one. And to do that, there's lots of things on the go. The most known one is our 130 Tesla trucks that we have ordered. First truck is going to arrive this year, and then we're going to start to incorporate that into our routine. We're also testing electric shunts in some of our sites right now. So these are really the two main ones from a big core emission standpoint. But it doesn't stop there, because the goal is not to reduce it, the goal is to be at zero. So we also have to combine this with quite a few other efforts. We have reefers on our trucks as well. What are we doing with reefers? What are we doing to manage the consumption of electricity and be a good corporate citizen and help the grid capacity as well? But also, how do we put less equipment on the road as well, with more 60-foot trailers, more LCV, or truckload optimization, moving more business at night that helps with traffic and with greenhouse gas emission as well, and eventually with electricity consumption. So as you can see, there's kind of two things on this. It's a good mix of innovation with electric truck, electric shunts, but there's also another bucket of just stronger, tighter blocking and tackling so that we can take those steps to the next level.
Awesome. Thank you very much, Francis, for the elaboration. Assuming that some of our audiences will not be familiar with the concept of electric shunt, could you please elaborate real quick on what that technology means, just to make sure everyone is on the same page?
Great question. So the shunt trucks are those small trucks we have. They're not that small, but they're moving the trailers from the dock to the yard. So that's what they do all day long. And then the actual trucks take the trailers from the yard and ship it to destination.
Awesome. Thank you very much, Francis. Great. So with that said, let's move to Frank. So Frank, in ABB, so it's your mission to create a low carbon future. So with your infrastructure, so ABB is supporting with digitally connected so-called ABB ability-enabled solutions and services. So what is your department's goal? And maybe this complements very well with all the ambitious plans that Francis listed. So could you walk us through your organization and the plans that you have for facilitating?
Yeah, sure, Nasrin. Happy to do that. So if you look at ABB as a big industrial company, which we are, obviously we have a plan to reduce carbon emissions. And our plan, we just noted down and recently published our 2030 sustainability strategy. And one of the key pillars in that strategy is really to reduce the carbon footprint and achieve carbon neutrality across our own locations, and also helping our customers significantly to reduce their CO2 emissions. And the target we set is like 100 megatons per year. And sites we put up, like new sites, and we're, for example, in my division, we built a new site right now in Italy, for example, for production, or we recently did a new R&D center in the Netherlands. And we look in all these sites to have them also from a building point of view and integration point of view, carbon neutral. And now another big driver, obviously, to achieve carbon neutrality is the transportation. And now being responsible for the e-mobility division in ABB, I'm very happy, of course, that this e-mobility is a significant drive to reduce the carbon footprint of ABB and of our customers. And this is an area. It's not a new area, right? I mean, it's now we really are at the break point, and hearing Francis talk about the electrification of Walmart is great, right? And then there's many companies doing now exactly that, because you can reduce your CO2 footprint, but you can also actually work on your TCO, on your total cost of ownership, and bring that down. So we started actually in investing into that type of business more than 10 years ago, which is really feeling like in more than in the last century in that fast-paced business. And we're currently partner of choice of many car OEM, of large CPOs, and yeah, I mean, this is America Summit, so I'm pretty sure, you know, like Electrify America, you know, EVgo, you know, Hydro-Quebec and so on, and you know, bus operators as well. So they all use also our chargers, right? And so to give you a number, since then we have now chargers deployed in more than 85 countries around the globe, 85, more than 20,000 DC fast chargers, and then close to 400,000 AC chargers, and also a lot of e-bus fleet, e-bus and e-truck. So we think with that, actually we're the market leader in that segment, in that industry. And also going forward, I mean, just to give you two examples, we just did an announcement that we work together with Amazon Web Services dedicated for fleet electrification. Can probably talk about that later. And also we just invested in a company called AFC Energy. It's more on the side of on the hardware side actually, but it's a fuel cell company because grid constraints are still there, and the question is, how can you move beyond and still do electrification and enable that when the grid is weak or non-existing? So we do that on that fuel cell basis. So that is just, I mean, a very wide range of what we do, and hopefully that answers a little bit the role we play here.
Great, thank you very much, Frank. You indeed set the ground for the discussions we are moving towards. In fact, managing the EV fleet and transitioning toward full electric vehicle operated fleets, it requires a holistic solution, right? We can't do that independently without considering the other factors, for example, energy demand from our buildings or the energy demand that we are imposing to the utility. And that brings us to our utility operator. So our electrical grid is one of the crucial elements in this transition. So because proliferating electric vehicles means more load on the 100+ years old electric utility. So let's ask Laura. Laura, what does a smart city mean to a utility like Hydro Ottawa? And how does a futuristic grid look like? And what is your role in the transition to the futuristic electric grid?
Yeah, thank you, Nasrin. So again, thanks for inviting me to join this panel. I think it's extremely timely. A lot of changes happening in the sector really quickly, and it's very exciting for everyone. So I think as both Francis and kind of Frank have brought to the table, there's a number of things that is happening quite quickly, especially the transportation sector has been transitioning quite recently. And I would say as the utilities, our job is really to be nimble and able to allow these transitions to happen, to offer cost-effective, technology-driven solutions to these or maybe Amazon or any of the other large services, as well as municipal transportation fleets are coming on as well. So Hydro Ottawa is a sustainability leader, I would say. I would say the entire province of Ontario in general is. We have a 94% clean energy grid. And so sustainability is obviously a really big piece of this. And so we want to ensure that we are enabling all of the other companies and customers that are out there to allow themselves to transition to a more sustainable future, and make sure that we can do so in a cost-effective manner, be ready for them, allow them to connect in a timely manner, especially with a lot of these private companies. Time is of the essence. They want to move quickly. They have extremely ambitious goals. They want to serve society and meet their sustainability targets. And there's a lot of challenges that utilities will face, and I think that's where technology really does come into play. And so the smart grid and the grid of the future, is the way I see it, is really allowing us to enable technology uses and utilize AI in a lot of cases in order to solve something that would normally take 5 to 6, 7+ years in order to provide the capacity demands that are being asked for in a much shorter time frame.
Great. Thank you very much, Laurie, for insights from the grid operator perspective. So we have heard from our panelists about the targets and the initiatives they have to bring electrification into their operation. So the next question is what are the challenges around this? These are disruptive technologies. We have been operating, it's not like we have been operating electric vehicles for decades, right? It's something new. So let's start with you, Francis. So what are the biggest challenges with the implementation of the electric vehicle? So could you give us your perspective from day-to-day challenges on real world that you face operating this fleet and also growing it? Slowly from, let's say, operating mixed fleet, starting with mixed fleet, because we don't go electric 100% all of a sudden. It comes to phases. So could you elaborate us on some of the challenges and what are the plans to overcome those?
Yeah, absolutely. It comes down to about three main things. The first one is it's the new factor. This is so new and it changes so quick. So what do you plan for? Do you anticipate the speed of change? Do you plan for 2, 3, 4 charging hours? Or do you plan for half of that because the technology is improving so fast? And how much of that technological improvement that you plan for? Because it is evolving fast and the trucks are not coming as fast as that. So you have to be ready to a point where you're not underestimating the progress of technology, but you also have to be realistic about where that's going to be at the point where you're receiving trucks. So that's the first one, is that new factor. The second one is the complexity around infrastructure, to Laurie's point. How much power do you bring at a certain area? For us, we're building some new buildings. We have a site with automation being built right now. This consumes a lot of power. I'm adding an electric fleet on top of that. So we're demanding a lot of power there, and there's a lot of complexity there, lots of challenges. We have to make sure we can accommodate that, working locally with the GTA folks who are supporting on that matter. And the third one is just how to integrate that with the fleet, because that's obviously it's a different beast. You have to find the right units going on the right route. You can't charge on the road right now. We're not there yet as an industry. So I cannot assign truck A to route B because that truck B might be going 800 kilometers away, and that driver will never come back. So this factor in the impact of winter on batteries as well. So we have to understand what degradation does when it's 0 versus minus 40 C. A very, very different story. So the complexity of integrating that and managing those new dynamics in how we drive the efficiency with our truck, because at the end of the day, we have to turn our equipment, we have to make the same commitments to the stores, to our supplier, we still have to deliver on time, do all those things, but we have to do it efficiently. So how to integrate those new pieces. So it requires quite a bit of effort, and it will require some smart tools. This isn't an Excel sheet conversation. This will require a few of the smart tools. We're contemplating tagging it along to some of our AI tools, some of our blockchain platform. Where do we pull from to have that very dynamic model built in, so that we can incorporate that, still deliver on our promises on sustainability, but run it very, very efficiently as we do that as well.
Awesome. Couldn't agree with that more, Francis. In fact, I'm totally in for deviating from Excel sheets and trusting AI-based simulators. In fact, in this scenario, I think the complexity of the problem is so large, and the uncertainties that stem from climate impacts, as you said, human factors, and battery degradation. So all these factors, it needs a smart simulator that takes into account all these different elements and cooks a scenario, a well-informed scenario. And I think that's important, not just in the operation phase, but also in the planning phase. Like how many EVs are are good to introduce to your system? Like what is the sweet spot in between the percentage of penetrations of EVs and the internal combustion engine vehicles, for example? So thank you very much for nicely elaborating that for us, Francis. And let's move to Frank. So I would like to get your opinion on this as well. Frank, so what are the, Frank had a lot of challenges, and some of the challenges also pertains to planning of the charging infrastructure. So for a fleet to operate properly, it needs a planned charging, a smartly planned charging infrastructure. So could you please give us insights from ABB's solutions on the charging infrastructure and smart planning of charging infrastructure?
Yeah, sure. So listening to Francis, I think first of all was quite nicely described how you put it, and on the challenges you face for Walmart and your fleet, and this is exactly what we hear in daily life. So you're not alone out there. So, but if I even go a step back, right, before talking on how we tackle all of this, there is even a more fundamental issue sometimes out there, which is simply how much energy do you have available at the site where you need it, right? So that's even a very basic problem. So we should not ignore that, right? Because sometimes you have just a certain availability of power, and I'm not sure on Laurie how flexible your utility is when someone comes and, hey, I need 4 megawatt now on this site, and I need it best in 6 months, right? So how quick are you to deploy that? And then how, let's say, and then each of the utilities, also there is differences, of course, if you generate, or let's say if you provide like 4 meg, is of course different what you charge for than if you have just 1 megawatt, right? So, and on all these differences also have to be taken into consideration. And then purely on the, let's say on the layouting side of such a site is also, the next question is, do you then want to put that all into one site? So like charge your fleet overnight in a classical depot, right? Is that the way you want to do it? Or do you rather say, we want to charge partially in that depot, but also during the day in breaks or at stops anywhere required, also do a charge? Gives you a couple of advantages on battery sizes, on cost of the vehicle, on flattening the curve of when you need the power and so on, right? So, but you also need to be able to do it, else it's pure theory. So this is, and this is then a fleet planning point of view. So, but going back to the site planning, then you have to play a bit with how you want to charge, right? Because the chargers, I mean, like ABB, we offer you all chargers. Tell me what you want, you get it. You want a 3 kilowatt charger, a level 2, no problem. You want to have a megawatt charger, we can build that, right? So everything in between. So that's not so much the issue. So, but it's more, the issue is more what is the right size of charger, and what is the right charging time? So how do you want to charge it rather quick, and then the rest is idle? Do you want to use the time up when it's parked? How much time is that? And that again goes then with the availability of power, right? So, and then you can also buffer that availability of power either with what I was mentioning, like to put a fuel cell in between to have green energy additional to the grid, or if the grid itself is enough, but not just in that period of time, you can also store in batteries in between and then deploy from the batteries. So all of this is also possible and requires a certain logic. So of course we can build all of this, but then on top comes then the challenge of the planning, of the route planning. So which vehicles do you want to deploy based on the battery size, on the state of charge, and yes, it depends unfortunately on the weather condition as well, right? So this for this there's algorithms which can be used, and to make a proper fleet deployment, to embed telematics as well. So this is like again what we do now together with AWS to drive that forward, and where we I'm just here in Berlin now, so where we build where we did a pure software plane for exactly that fleet deployment, right? And also have a couple of customers really with whom we guide that process. So really, we have to tackle it from both sides. What is available from a hardware to plan that smart, because there you can sink millions of it if you do it wrongly, right? And or if then you're not operational, and if you don't have proper backup, etc. So that needs to be really thoroughly planned from a layouting, and then obviously also on the deployment and running and operating the fleet itself.
Great, thank you very much, Frank, for elaborating it nicely, how challenging, in fact, operating an electric vehicle and infrastructure planning is. As you said, there are many dynamic factors that needs to be taken into account, and from operating the electric vehicles itself into climate effects, into how much energy can we inject to or from the grid. So there are many different degrees of variables that needs to be taken into consideration. So thank you very much for establishing that. And this also shows how challenging it will be for a utility operator to accommodate all these demands. So Government of Canada right now gives it is investing about $2.7 billion to electrify their transit systems across the country. So this motivates the electrification of transport, but also it means that, as Frank and Frances stated, it means that it will bring a lot of challenges to the operation, both from the fleet operator side, but also from the grid operator side. So my next question is directed to Laurie. So Laurie, let's deviate a bit from operating the fleet and its challenges into accommodating the energy that it needs from the utility perspective. So right now, all these fleets, basically you will become a pumping station for these vehicles. So what does that mean? Could you elaborate the challenges that brings to the utility, and what are the limitations that really a grid operators should consider while planning and operating this infrastructure?
Yeah, for sure. So I think the government's announcement of the $2.75 billion really, in a lot of ways for Canada, anyways, signifies that switch for municipalities from using a traditional gas station into the utility becoming their gas station. Ottawa, our city that we serve, recently did announce as well that they were going to be taking advantage of that funding and significantly increasing the number of e-buses that they'll have on the road over the coming years as well. So we've started working with them, and it's a pretty quick realization that the impacts are quite substantial, and the demand that they're requiring is very high. So there's a unique situation now where we have to work very closely with the municipalities as well as all of the other customers that are coming in with these demands in order to understand what we can do to accommodate these extremely large loads and allow them to meet these expectations. So it's really interesting to hear Frank, for instance, like the stuff that he's bringing forward in terms of how they can interact with the chargers and how they can set up the chargers in order to change the energy draws and how much what demand they need and at what time of day. So that's something that we obviously need to be mindful of, and we need to be working as utilities closely with the EV charging providers as well to understand what our flexible options are, because in a lot of cases we don't in our distribution network in order to actually supply the demands that are required in order to enable these really large charging infrastructures to come online. So, and then the second piece that can happen is that it can actually, we might not even have transmission capacity, and transmission upgrades, I'm not sure if Francis has had to deal with this at this point yet, but transmission upgrades are incredibly costly. And then if there's also the cascading effect of that is you go across an entire province where everyone is suddenly demanding more electricity all at the same time. And in Ontario, we're a provincially controlled grid. What that means is even more generation capacity needed to be added overall in across the province in order to supply that demand that's being requested. So what ends up happening is like there's obviously extremely high investment levels, and those costs in the end, they roll down to the end user, to the customers, to the residential payers, even to that point. So what we're looking at from a local distribution company perspective is how can we avoid those lines and wires and the really extremely high cost investments into capacity and transmission, and instead leverage technologies, leverage AI in order to solve the problems using either demand response auctions or battery solutions, battery storage solutions locally. How can we deploy other alternative technologies and work with even existing customers to reduce the overall demand that they have on the grid so that we can free up some space and some capacity that's already available in order to serve these new customers. So I think that's really our role in this space is to figure out how we can solve things in more new and novel ways and not have to incur extremely high and long lead time costs on our customers.
Great, thank you very much, Laurie. And in fact, that stresses how important it is, the energy management, intelligent energy management of the fleet demand. In fact, to reduce the stress on the utility grid and basically either circumvent or delay these infrastructure upgrades, which, as you said, they are costly. And I think if I may complement what you mentioned, I think being able to also respond into demand response programs that are crafted by utilities and taking that into account while doing energy management, I think that's also an important piece, I believe. So I believe that there are incentives or regulatories around when are the best times for electric vehicles to charge. Can you comment on that? Like, are there plannings to impose, let's say, nighttime EV charging rates, for example?
Right now, in the province of Ontario, you pay for your demand on a time basis, but it's whenever you're peaking in your demand, but the rates don't change depending on the time of day. So there is a lot of conversation happening, lobbying happening within the province of Ontario to actually create offset rates so that the demand that you pay on, say, a nighttime charge where there tends to be less demand on the overall provincial grid or the local grid is at a lower total capacity or total demand, sorry. BC Hydro did actually successfully implement a rate structure of this nature, and it is very much to incentivize this off-peak charging, and where we don't end up having this coincident peak issue happening where customers in general that are bringing EV fleets on are trying to charge at the same time as, say, a manufacturing facilities or other facilities that operate during the daytime, and then you have all your office loads and everything else, right? So if you can push some of these extra high demand new loads into the nighttime, then overall your system needs can become much lower, and you can avoid some infrastructure upgrades.
Definitely, definitely. In fact, intelligent energy management can actually shift the charging not only in time, but also across the network if the intelligent energy management is done with consideration of not just single depot maybe, but with consideration of all different multiple depots that a fleet operator operates. So thank you so much for that insights. So we have established the challenges that exist in the real world to facilitate integration of electric vehicles into our fleet. And now I'm quite excited myself to indulge into the topic of AI and how AI actually can help. So I think with all these different challenges established by our panelists, and the fact that we need to take into account various different considerations in order to proactively make an optimum decision in real time. So this shows the need for leveraging data-driven control mechanisms. So one of the advantages that data-driven control mechanisms bring is that it helps us to have insights into characteristics of our operation. So what are the sizing requirements for our assets? How much energy do we need in real time? So what are the impact of weather or my driver behavior into the energy that my truck needs, and so on and so forth. So it helps us, the data helps us to make realistic assumptions when developing our models, and even better, rather than crafting mathematically complex models, why not leverage AI to actually learn and operate from our data? So with that established, and knowing that data is the fuel to our artificial intelligence algorithms, let's indulge into the topic of data. So how valuable is it to measure and record your operations data? And what are the opportunities and gaps that you see in data for decision making in your operations? So that's a question I want to bring forward to our panelists. So would you like to start? Maybe Francis, or and then Frank can add to it?
Yeah, I could start. I think there's two foundation blocks that are mission critical to any of those conversations. And the first one is we need to have strong data lake type of approach and make sure we have good, reliable data. Because the truck data, trailer data, GPS data, all that's got so much better throughout the years that there is good data out there. So you need to have it in a good place, hosted in a good place, managed properly. So data lake type of conversation. And I think the second foundation block for me comes to metric alignment. You're going to have some KPIs. You're going to have some key indicators you're going to review with your team, with your operators. Some are going to be lagging, leading. But you need to have clear definition of your KPIs. When I started at Walmart, as you know, a quick anecdote, I looked at truck utilization, and we had 3 different scorecards with 3 different ways to calculate truck utilization. So that's a metric alignment conversation. We agreed on one, and then we're going for it. And once those 2 foundational blocks are done, and we're working on both now, and for us, we're going to integrate all the new information that we want to enter in the pipeline with our electric fleet. Then we can throw all this in some of those tools, right? AI, blockchain platform. We have our Forekites platform as well that gives us machine learning ETA. So that becomes very, very, very powerful. We're at the point where it's helping us with a lot of the lagging indicators right now. And it really is evolving towards a more proactive control tower approach, where we're going to have more dynamic report, more dynamic view, and be able to take more proactive decisions upstream for us.
Great, thank you very much, Francis. Up to you, Frank.
Okay, so I again look from 2 angles. One angle of the data is obviously the data on the infrastructure itself, right? So kind of on the asset. Because the worst thing which can happen is if the fleet comes back, should be charged and cannot be charged, then yeah, it's a nightmare, right? So you really need to have all the data to know what is the status of the equipment, how is that, if something fails, how could you reshuffle, what is your redundancies, etc. And the other is obviously for the fleet itself, and I think we touched on a lot of points already now, so it's probably a bit repetition, but the telematics and the routing paired with the availability of energy in the batteries and the replenishment of those, this is key, right? And it circles all around that. And that differs by the route, that differs by the type of vehicle you use, by the load you have, by the weather condition, potentially by the driver, right? And the more you can optimize that, and absolutely a tool to do that and to learn and to go forward. And yeah, the more you optimize here, the less cost you will have. And for any professional fleet operator, this is, of course, money in the pocket, right?
Definitely, couldn't agree more. Thank you very much, Frank. Laurie, would you like to add to this discussion?
Yeah, so I think like it's interesting that like as a utility, we're very akin to playing with real-time data. We have our SCADA system, obviously, we operate the grid in real time. So it's not something that's not new to us. In the city of Ottawa specifically, we have deployed a fiber network as well throughout the entire city so that we can have real-time data. The one thing we don't use our real-time data for, though, at this point in time is to actively interact with our customers. So we don't act in any way as a local distribution system operator. And so we don't, at this point in time, and neither do any of the LDCs in Ontario, for the most part, interact specifically with our customers in order to control their assets or in order to actively manage them. So that is something that I think is an open and existing that I think we're also going to have no choice but to kind of basically learn how to do in the future in order to better leverage available technologies and get these guys kind of solutioning more creatively, I guess you could say. So.
Great. Thank you very much, Laurie. I will quickly move to our last topic, and then I would like to open the discussion for Q&A from the floor. So audiences, please do type your questions in the chat box, and we will try to accommodate them. So my last question comes to operationalizing AI in the real world. Now, we know one of the challenges that AI-enabled technologies have in the real world is that they need to sustain the quality of their performance in spite of the poor quality data. And poor quality data is inevitable. So real-world data is never clean. It comes with anomalies, missing data, various issues, and one operating in real time in the real world needs to anticipate for all these anomalies and craft and engineer a solution around it. And having said that, particularly for the problems or novel applications, anticipating such problems is very difficult. So what kind of, I will ask this to Laurie first, what kind of anomalies or data quality issues that that they are common in real-time operations? And how crucial is it to make an optimum decision in real time for your operation?
Yeah, so I'd say, I think for the most part, probably across North America, and I would say almost in a lot of cases worldwide, where the real-time data is available in the meters. So the meters, in a lot of cases, there's a meter on every single service point, and they offer optionality in order for us as utilities or as grid operators to have that insight into some of the stuff that's going on in real time. But what we don't have is the actual technology installed from a communications perspective and the back end software that's required in order for us to actually actively operate our grid in real time, or even somewhat real time, say semi-real time, say 5-minute delay or something of that nature. And so because we don't have that data, we actually don't necessarily know even what we're missing or what the opportunities could be. So from a utility perspective, I would say that's actually probably our current first and foremost challenge, is to be getting ourselves to in real time interact with our customers so that we can get that data available, so that we can start operating in a more technologically advanced space and actually trying to solve these problems in more real time rather than relying on 24-hour-old data where the problem's already passed in terms of solving some of these issues. So it's a huge opportunity. It's a completely untapped space, I would say, at this point in time, and something that we're definitely very interested as a utility in moving towards, and further leveraging technology, AI, working with a company like BluWave-ai, obviously, to try and solve some of these issues.
Great, thank you very much, Laurie. And I would like to take Francis's perspective on this as well. So walk us through what kind of anomalies or data quality issues that is common in EV fleet operator.
Yeah, I'll give you a complex one, just one example to try and explain it. Like, we're using machine learning ETAs to anticipate what life's going to throw at us. So we have a snowstorm in Western Canada, and so we're going to have 50 loads crossing the mountains, and the mountains might be closed for a few hours, a day or two. So we're trying to really manage this proactively and understand when do we make the bold decisions and we ship trailers half full, so that we can actually beat the storm, make sure drivers are safe, but we still have product on the shelves, or do we hold on and we're ready to go right after the storm? So that in itself is a quite complex algorithm, and we're struggling to make the right decisions at the right time. And the more we do it, the more repetitions we have, the more the algorithm learns, and the more we can make good decisions. But then we add the electric component of it, and it really adds 6 layers of complexity, one shot. Because now, if I get stuck in a snowstorm somewhere, well, I might run out of horsepower to come back. I might not have enough electricity to come back. Then there's also the timing shift is different. If I make a bold decision to ship 50 trucks earlier because I want to beat the storm, make sure my goods make it on the shelves, it's okay today. But tomorrow, those trucks might not be charged already. They might have not been back. I might not have enough time to do it. So maybe I can't do it. So now we have to factor in those very dynamic variables into a process that is super dynamic and actually fairly new. We've been at it for about a year. So it's going to add a good degree of complexity. So I think we're going to have fun with this one.
Definitely, definitely. Great example, Francis, actually. I'm looking at the chat box, and I think I can deduce one question from our audiences. So the question revolves around, well, it is a best practice to deviate from Excel sheet analysis and use a simulator. But the question here is, what if you don't have any data? So no historical information, then how do you start building that? So, I mean, Francis, would you like to take that question and then I will add to it?
Yeah, I took a crack at it on the chat just to trying to address the question. I think you got to go with what you know. There's spec, there's some public information what the suppliers are working with. They're the experts, so that's the governing rule to start. I think you have to review this 9 times. You got to create a safety net because this is so new that, again, you don't want someone stuck somewhere. You don't want to run out of truck. You don't want any of those situations to happen. And then you got to review, and review all over again 26 times before you press play. And after that, it's, to me, I call it plan, do, check, act, but on steroids, right? You really have to do a loop, and the deviation might be smaller, the variability might be smaller, but then you adjust and you drive more and more and more precision after and after. So, you got to create that safety net. You have to be very, very diligent, take your time, and then evolve very, very quickly.
Great, thank you very much, Francis. And I will add to it by saying that it is possible. There are simulators out there, and in fact, BluWave-ai has designed a simulator that takes into account all these factors and deduces various scenarios. But more importantly, we do take third-party data or publicly available data or data from various different resources, or to basically map to map a correlation, to analyze a correlation between operating ICE vehicles with electric vehicles, to be taken into account that into our simulation. In addition, we also get third-party data to simulate what would happen if a particular fleet would have been operated in different parts of the world. So that also helps to basically transfer the experience from one operation to the other, I would say, in a scenario when an operator doesn't have a historical EV fleet operation data. So we are near the end of our time. So I would like to conclude the session. So first of all, thank you so much to our panelists. This was a great insights from what happens in the real world, what are the challenges out there, and why is it important to take into account and use the data-driven algorithms and technologies into our operation. And as a closing note, I would like to also introduce BluWave-ai EV Fleet Orchestrator. So our EV Fleet Orchestrator offers a novel solution. It is built on top of BluWave-ai's distributed AI platform, and it optimizes energy costs in real time by consolidating all these many parameters of energy and fleet operations that was listed today in today's discussion. And it provides a holistic view with coordinated energy dispatch and control. So we pulled together 3 different elements. We intelligently manage EV fleet charging and dispatch by factoring in the energy price, peak demand constraints, equipment schedules, and considering constraints such as equipment service requirements and routes. The second element is that we also try to integrate solar generation and battery energy storage to the system, because having a local generation and battery storage, as Frank rightfully mentioned, it reduces the energy costs and emissions through considering load, energy prices, and solar output. And finally, we also take intelligent management of mixed fleets as one of the factors, because most of the operations will start operating a mix of gas-powered, hybrid, and electric vehicles. So the EV fleet orchestrator effectively manages such mixed fleets and factors in the ambient temperature, again, energy prices, optimal battery cycling, and more. So with that, I would like to conclude this very exciting, very fruitful discussion. And please contact us if you have further questions from us or from our panelists. And I would also like to mention that the recording of this discussion will be available, and the audiences will receive an email about the specific and with a specific link to access it. So please contact the organizer for more information on that. Thank you very much, our audiences. Thank you very much, our panelists, for this discussion, and have a great day, everyone.